Hi, welcome everybody for a conversation with David Burns. He's the principal mechanical engineer at Molex, where he leads the development of high reliability components and systems in safety critical applications. With his PhD in engineering from Northwestern University, he applies data science, simulation, and technological innovation to cross sector industries that design for safety, including automotive, agricultural, construction, and medical. His work is rooted in rigorous analysis, interdisciplinary thinking, and a commitment to building solutions that perform under pressure. Sounds complex and really important, David. So thanks for taking time this morning to join us.
Thanks so much for having me. Excited to be here.
We've heard you talk about the idea of engineering with purpose. First of all, tell us what that means and then what got you on the path towards that.
Absolutely. Engineering with purpose, to simplify the idea, I think, in my mind, is making sure that your solutions solve the problem at hand. And although that sounds maybe basic and obvious, what it means to me is a lot of times when you're engineering solutions, there's a lot of noise that can come in as to product improvements or areas that you can make a solution what you think is more attractive to more customers. At the end of the day, though, the best solutions are those that solve the problems in the most efficient way. And using that as a guiding principle, using that as the purpose of going into an engineering challenge, seems to always lead to successful results.
You stick with the original problem and the rootedness. Do you ever find, David, as you're going into the situation, that the problem's not the problem or that it evolves and you have to rephrase
Almost
it?
always.
Okay.
So I made it sound simple, engineering with purpose, when really it's an ongoing task. It's iterative and it really never ends. The idea is when you get a initial problem statement, I would say 99% of the time it's incomplete, and maybe 50% of the time it's not even the actual problem that the customers or the industry wants to solve. Rather, it's through the development process that the question that you're trying to answer, that the problem you're trying to respond to becomes clear. So that's where you get into development as a ongoing activity.
Got it. Got it. So that sounds like there's a lot of human element into managing all that complexity, the noise that you mentioned, the purpose, the priorities of the different stakeholders. So how is it that you hold on to the reins and keep guiding the project when all that complexity collides with, and things like expediency and cost collides with the real world of complexity?
Great question. The actual task at hand is one of understanding each of the, I think of them as stakeholders, but sometimes they're not people. They're concepts or they're areas of the solution, the eventual, hopefully successful solution that contribute towards that success. So when you're talking about managing these different areas, the first step is understanding them. You can't manage them before you know what they themselves are trying to fulfill. So taking as a very simple example, let's talk about reliability. Let's say that a product needs to last 15 years in the field. The first question is, how is that defined and why 15 years? Those questions that get down towards the what birthed the requirement are as important as meeting the requirement itself, in my mind. And really that comes down to having the right people and knowing the right way of getting to those answers from a technical standpoint, from the people within the organization that can dig down and perform the analysis that can answer those sort of initial questions.
So is it a combination of analysis and conversation, or how do you find out what the real motivation was?
Absolutely. I'd say conversation number one. First, talking to everyone that could have a part of the answer. Analysis is ongoing. Analysis is every day. There's a change to your initial concepts that might change your hypotheses in the moment. In the reliability example I gave, what you would want to do is talk to someone who uses the product or uses a product that you're trying to, for instance, replace. Get you the first step towards knowing what is the true need that this requirement originally set out to guarantee.
So people are saying this washing machine breaks too quickly,
That's
or
right.
this is too difficult to work with. That
Mhm.
then gives away why there's a different sort of need emerging.
Right, and maybe even deeper, what breaks? What is broken?
Why does it break? Yeah. So you're balancing data and design and then the way the system behaves in the real world. First of all, tell me when you say the word system, what are some of the key elements of a system?
Now, a system, I always go back to a thermodynamic definition of a system. That's probably the engineering basics in me that refuse to stop trying to guide the way I think. But thermodynamics has a distinction between a closed and an open system as it pertains to energy as well as matter. Disregarding those physical aspects, a closed and an open system are good concepts on what you can bound around each product. So, for instance, a part that goes into, for instance, some sort of safety critical system would, as the bounding box of its system, not only include the product and not only include the device for which it is a component, but would also include users and those affected by the system, by the device, I should say. Your system in that way is much larger and is probably what we would call an open system in this concept, because your users are going to change and the people that are affected by it are going to change, as well as all of the implications towards industry and infrastructure that might be affected. So a system really can be as enormous as it needs to be until you stop having it's a negligible effect.
And how do you determine when it's big enough or inclusive enough?
It's a great question. Maybe an assumption is made that you would stop the analysis at the end user when really there is a customer of the end user who might be affected in a different way. As long as there's a appreciable different mode that they can be affected by, ultimately your product, they have to be included.
So, what's coming to my mind now as a leader, you're thinking of these core concepts and principles that guide your thinking. How is it that you lead and engage your team, your customers, other people to think that way and realize what to include and not to include and why in a system analysis?
Okay. Yeah. I'd say my philosophy for my team, for those internal to the organization, and especially those that have the same goal as me on this development of product. My philosophy would be understand their personal strengths, areas of development, motivations. I think those core points of understanding can only help a team be more efficient and run smoother. That might be a way of facing an internal team that gets me to the point of knowing that I have confidence in what my team can and can't do at the very end. Then, when we talk about as we look outside, you would be in a case where the customer really needs to be a partner, especially in the development of product where that system we talked about expands beyond the customer, that there are people affected even beyond the person who's purchasing the product. We really can't think of them as just an external, an external body that has no interaction. In all of the projects that I've run, there's at least some element of partnership that needs to be there between the customer and the team itself.
Do you ever get pushback or feedback like, oh, that's not important, or that group is not important?
Absolutely. I'd say that is a common feedback. And I would also argue that it's an extremely important piece of feedback. From my point of view, that's part of the ongoing iterative analysis that guides the scope of the project. That point of view, we could say, is entirely important, especially depending on who it comes from and what their end goal, what that group's end goal might be. And so I might get this from leadership in my own organization. I might even get this from an external source. I might even get this from a team member. And in all cases, I would say it tells me something about my current hypothesis, which may or may not go into some sort of change of that internal hypothesis.
So then how do you, if you will, negotiate or co-develop a new path?
Yeah. Well, there's the work. The negotiation that you're describing, and the let's describe it as a change in your current way of operating based on some feedback, based on some new input. It all comes down to weighing its impact. I'd say if you're given some input, for instance, we're over and like this might be from an internal source. We're over engineering our product. We know that the goal is a 15-year life. So why do all of our tests test for 30 years to make sure that there's a reliable option 2x? What is the impact? What is the impact to cost? What is the impact to the schedule, to getting the product to market? Are these deliverables, we could think of them, are these quantitative elements themselves outweighing the advantage of having this higher reliability confidence? And that's where it all comes down to. Weighing those getting everything as quantifiable as possible is probably step one. And then it comes down to weighing them and taking risks that make sense from a potential gain versus the potential loss.
So, an allied question is innovation. So, how is it that you're driving innovation in a complicated scenario like you just described?
Absolutely. I've got a few very key mentors in my current role that are focused on innovation and have been for decades. It really has guided their career. And I myself aspire to the same sort of achievement as far as prioritizing and sustaining innovation throughout multiple product cycles throughout my career. I'd say the things I've learned so far are one, innovation as just a noun really means no more than prioritizing the unknown over the known. So if you get to a state where you are developing for a fully known system with key question and answer that gets you to a known final state, I wouldn't call that true innovation. I'd say innovation by necessity, by definition, must have an unknown element. What that means day to day is allowing for the idea of a spec sheet, maybe something that describes all the specifications you're trying to meet, to have a question mark on it, to have an area that says, we don't know the answer to this. There may not be an answer the way we want it to be that solves this problem without affecting some other aspect. But it's worth it for us to drive towards an unknown goal. I'd call that innovation. I'd say or rather, I'd call that the stage for innovation. Innovation itself, of course, that's the hard work. That's what goes in towards making the right research choices and investigating the output and analyzing it well enough to guide you towards the next question. I'd say that loop is probably what sustains engineering, at least in the area of my career. So I said that was number one. Number two, I think, from an innovation standpoint, is giving room. So the driving force of an organization seeking profit is to make the product that more customers want. As a offset, or maybe I should say that a sometimes result of that, you sometimes get a drive within an organization to push towards a known successful point. There needs to be, in a future looking organization, additional drive, maybe even a completely different team that is given space to do this iteration. And that means not demanding an output of them that is a known result. So what I've learned from some of my mentors is there are these loops of some given amount of time where you wall them off and allow them to do this iterative work without expectation of daily updates as to progress, what we otherwise think of as progress. So sort of with those 2 points, with framing the question right and then giving them space to answer those questions, I think is probably how I'm currently facing innovation.
How do you show that it is worth it, especially as it's unknown?
Absolutely. I think that's the reason why true innovation has a hard time becoming a more mainstream element of every company, is because it's difficult to appreciate its effects financially. I guess I should say just efficiency wise in the short term. The demonstration of value in an innovation heavy group would rather be pointing towards the products that have made they've beaten the estimation of how that product should perform, and that can point back towards some innovation. And that can be as simple as an easier way to make this product, or some different cheaper bill of materials, something that makes it so that it's more cost effective and more customers want it. At the end, it's really the incumbent on the manager who wants to drive innovation to highlight those cases. And I think that's a difficult part of the job, because then what you say is, look at these past successes. You won't see successes like that until the future, until what the current group is working on can make it all the cascade out into the products that we're facing.
So, an allied question there is, where does precision and predictability meet adaptability in organizations and innovators and engineers?
They'll be hand in hand. The two, which seem like they might be in conflict, the idea of getting the right answer and also the idea of responding to new questions, although they seem like they might compete. They might hurt each other, as far as if you spend time on one, you won't be able to spend time on the other. I think that's the wrong way of framing the question. I think instead we should think about the idea that a right answer depends on asking the right question. This goes back to what I was speaking about earlier, that the bulk of the work is really in defining the question right. And that really touches on this flexibility and adaptability. If you aren't ready to change your question rapidly, your answer can't possibly be correct. And so your precision, what you would measure as precision at the end of the day, sure, you answered a question, but it's no longer the question you're trying to answer. It's no longer the goal that the product should be meeting.
So, describe then the mindset you take as an innovator, and I would even say as an entrepreneur, somebody who builds new businesses or new ways of doing business or product development. What are some of your mindsets and perceptions and beliefs that you carry with you?
Well, let's see. As far as the entrepreneurship, I'd say that's a big part of what I've been trying to push towards in a innovation centric group. That is knowing what capacities your organization has, discovering these capacities really, and then giving them the ability to affect the answer to the problem. As a very specific case, I'd say I've been very careful in identifying experts in various areas of the development of a product. And that doesn't just touch on designers. That doesn't just touch on manufacturers and the analysts that go into product design. But what I'm really trying to establish here is understanding who this team can include to better improve the product, even when it's completely outside the normal group of people who go into developing a product. I'd say it's something that I improve at every day, and I'm still trying to improve at. That's one of the areas that I see the value in, and I know that I've got a ways to go to make myself most effective at that.
How do you borrow them or recruit them in terms of their time and other priorities?
Yeah, I guess that has a dual aspect that goes down to motivation as well as access, just having access to the person's time. Motivation is probably the first thing that needs to be captured, and that is understanding what this person, what this individual might want, what their goals are, and where they see themselves contributing. I think that just is conversations. That's just talking to people and understanding, where they're coming from and what they like, what they want to contribute to the organization. There's been a number of times I've found people who are interested in developing IP, interested in pushing the company's capability, who haven't been given the chance merely because their role doesn't necessarily have that as an expectation. Then on the other side, so that's motivation. Access is probably the secondary step and can be either very, very easy or it can be difficult. I've found that there's very little middle ground here. It's finding the organizational structure that's going to give you the ability to use that person's time. And it comes down towards the people involved. In this case, within their organizational hierarchy. Within that structure, you'll find people who are very open towards this cross-pollination and those who aren't. And if they aren't, really it just comes down to trying to convince them by giving a good example of what the profit could be to both sides. Within an organization, it's pretty easy to say, we rise together. We're all one organization. When it's outside of the organization or some sort of affiliate, that's where you have to get creative. And I think that comes down towards conversations again and making sure that there's a known benefit that both sides can reap.
It sounds like you're a great practical networker and sincere.
I hope so.
So, last question has to do with I can tell by all of your examples that you're really good at blending the technical and financial side of the business with the human side. So, how do you keep that link hot, if you will, and designed for impacting the whole system, meaning both sides?
Absolutely. Well, I've been thinking a lot about the human side, especially lately as generative tools become much more common, especially in the workplace. You'll see generative tools being pushed as a necessity, and I think that as a tool to make work more efficient, there's a lot that needs to be grasped. What I think is not lost, what is not something that we are even close to eliminating with tools like these is the need for having an, a human critically in the loop when decisions affect humans. That's maybe a very simple way of stating it, but I see a even increased need now that generative tools allow technical output to just become exponentially more common, easier to generate, easier to pass on, and as this output builds in quantity, so too builds the need for decision makers who have take ownership of the decision themselves. I've been in many cases where I think I've seen the effective state of this generative output being used as a tool towards making a more complete decision, using more input so that your hypothesis has a better confidence level towards reality, towards whatever we believe is base truth. I believe that's probably the optimal state. Having a human in the loop and allowing this analysis to ultimately pass through someone who is responsible for the decision, it's not going away.
What does the human, if you will, bring to the dance that the tool doesn't? What does the human know and understand and have the power to see that the tool does not?
It's interesting when people talk about especially generative output, but even just the output of traditional analysis. We've been using tools for forever, and although generative tools appear to be some step change in what this output means, I'd say not so. We've always had the ability to aggregate. We've always had the ability to take data points and make decisions based on them by combining and recombining and focusing on some aspects. This is no different in that the input is still what humans have generated, what humans have put into the system. Although now it seems more like a black box that what we get out appears to be have some sort of alternate way of genesis, I would say that not so. It really just all it is today is a much larger quantity. We're really looking at quantity increase now as far as this decision making data coming out of our tools. What the human is bringing today and has always brought is the interpretation of this quantitative output towards solving the goals at hand. As these goals shift and as these goals become more and more close to the question we're trying to answer, we will always have the requirement of a human who can stay flexible, understand that the question is changing, and interpret our incoming information towards answering that problem with critical thinking.
Okay. Thank you. David, it's been a delight. I could stay on for another hour, but we know we both have other work days.
That's right.
Let's talk again sometime. And it's
Absolutely. Well, the pleasure is all mine. Thanks again.
thank you.